For the past few months, I have been working on the security docs for CockroachDB and have learned a lot of interesting things. Here's what I've learned. An insecure CockroachDB cluster comes with serious risks. Your cluster is open to any client that can access any node's IP address. Any user, even root, can log in without providing a password. Or any user connecting as root can read and write data to your cluster. To avoid these security risks, CockroachDB provides authentication, encryption, authorization, and audit logging features to deploy secure clusters. In the previous video, we saw what these features mean. In this video, we will see how they work, starting with authentication. In a CockroachDB cluster, the nodes can communicate with each other and with the apps and SQL clients. A secure CockroachDB cluster has authentication set up. Authentication refers to the act of verifying the identity of the other party in communication. In internode communication, authentication involves verifying the identities of both nodes. In client-node communication, it means verifying the identities of a node and a client. CockroachDB uses TLS 1.2 digital certificates for internode and client-node authentication, which requires a CA certificate, which is shared across all nodes and clients. It also requires keys and certificates for nodes and clients. To understand these terms, let's go back to the analogy of the previous video. A digital certificate is equivalent to the identity card that has information about the card owner. The certificate is signed by the certificate authority, which is equivalent to the security officer who validates the information provided by the person and signs and issues the card to the card owner. The security guard uses the security officer's signature preloaded in their system to verify the signature on your card, and if they match, only then your identity is authenticated. So not only you, that is the card owner, needs the security officer's signature, but also the security guard needs the signature. In the digital certificate scenario, the presenting and verifying entities need to have the same CA certificate. So in internode communication, all nodes need to have the same CA certificate. The node's digital certificate that is signed by the CA is presented to the other node. The second node verifies the certificate signature using the same CA certificate. Same procedure is used for verifying the second node's identity. Similarly, in client-node communication, the node and the client must have the same CA cert. The node presents its digital certificate signed by the CA, and the client verifies it using the same CA certificate. Same procedure is used to verify the client's identity with the client certificate. Thus, the basic requirement for digital certs-based authentication to work is that the presenting and the verifying entities need to have the same CA certificate. Things get more complex as we start considering more advanced security scenarios, such as split node certs and split CA certs and UI certs. But these scenarios are easier to understand if you remember the basic requirement that the presenting and the verifying entities must have the same CA certificate. For a deeper dive into how digital certificates work, you might want to check out the authentication document. The document also describes the complex security scenarios in detail. I will leave the link to the document in the description box below. Moving on to encryption. CockroachDB supports encryption in flight as well as encryption at rest. Encryption in flight is implemented by encrypting all internode and client-node network communication using shared encryption key as per the TLS 1.2 protocol. Once you set up authentication, encryption in flight is done by default. Encryption at rest is an enterprise feature that you need to enable. Encryption at rest is performed at the storage layer and configured per store. It uses two layers of keys, data keys that are used to encrypt all files on disk, and store keys that are used to encrypt the data keys. For more details about CockroachDB encryption, see the encryption document. You will find the link in the description box below. Next up, authorization. Authorization or access control means only the users who have privileges to interact with a database or a table can access it. CockroachDB allows you to create, manage, and remove your cluster's users and assign SQL level privileges to the users. Additionally, if you have an enterprise license, you can use role-based access control for simplified user management. To know how to use these features, see the authorization document linked in the description box below. And finally, SQL audit logging gives you detailed information about the queries being executed against your system. Again, link in the description box below. So that was an overview of the security features of CockroachDB as of the publishing of this video. So I recommend that you check the CockroachDB docs and release notes regularly for security improvement updates and new features. I hope this video was helpful. Thanks for watching.